All right, so we have tables and tables and tables of standard enthalpies of formation and standard enthalpies of combustion and other enthalpies. But sometimes you don't have the enthalpy value that you need, and you need to combine things that you have to get what you need. And that's what Hess's law does. So for sure, there are tables of standard enthalpies of formation of almost every compound we know of. There are also some enthalpies of combustion, but the whole point of Hess's law is you don't have this standard enthalpy. You want to know it. Bless you. So you take things you have, combine them to get the thing you need, basically. And yesterday, the example I did was to calculate the standard enthalpy of formation of this thing, ethane, given the following combustion data. So we know if we combust carbon, it releases this much energy. And if we combust hydrogen, it releases this much. And if we combust that ethane, it releases this much. Use that information, rearrange the equations to get the standard enthalpy of formation equation. And then you can combine your enthalpies. Do you have questions so far? Did what I showed yesterday make sense? Kind of? Okay. Let's do this one together. The thermite reaction was used to produce molten iron for welding railway tracks together. So we have the overall reaction, Fe2O3, iron 3 oxide, plus aluminum makes aluminum oxide and iron. And our goal is to figure out what is the enthalpy change for that reaction. We want that. We don't have a table for that, so we have to get it some other way. Then it goes on to tell us the enthalpies of formation of iron 3 oxide and aluminum oxide are that and that. Why don't they give me enthalpies of formation of aluminum and iron? What would the enthalpies of formation of those be? How much energy is released when I have this reaction? 0. Same thing for iron. Anytime you have elements, just elements by themselves, those are 0 enthalpy of formations. Okay, so the enthalpy of formation of iron 3 oxide. So enthalpy of formation is this. Iron plus O2 makes iron 3 oxide. 2 irons, 3 halves of an oxygen is negative 823 kilojoules per mole. Aluminum oxide is aluminum plus oxygen makes aluminum oxide. 2 aluminums, 3 halves of an oxygen, and that's negative 1675. Okay, so now that we have our enthalpies of formation, we need to combine these two reactions, rearrange them, to where we have this as our overall. That's our goal. So, I need iron oxide to be a reactant, not a product. So I'm going to flip this whole reaction. And I'm going to rewrite it just so you can see it. If I flip it, I wind up with iron to 3 oxide goes to 2 irons and 3 halves of an oxygen. And if I flip the reaction, I flip the sign. Positive 823 kilojoules per mole. So this is gone. We don't have this anymore. It's this now. Now I need to check and make sure that things cancel so it ends up looking like this. At this point, the only thing that cancels is I have 3 halves of an oxygen as a reactant and 3 halves of an oxygen as a product. Those go away. Now I have 2 aluminums plus iron 3 oxide makes aluminum oxide and 2 irons. If this matches this, and it does, you can add up your 2 values and you get negative 852. Make sense? So Hess's law is all about taking things we have, enthalpy values we have, enthalpies of formation, and combining those reactions to get the reaction we need to find its standard enthalpy value. Because we can't possibly have a table of every enthalpy ever. We can because of the internet. But before, they just used to have like books, and you couldn't have a book with every enthalpy value ever because it would have been a library. So they came up with this idea of Hess's law to combine different reactions and get your enthalpy value that you need. Okay, that's it. All you need to do is finish your worksheet. If you have questions, let me know. That's it.